Ever asked ChatGPT something and it confidently made stuff up? Yeah, happened a lot to me recently. I bet to you too. The thing is, it's not the only problem. I have to know a lot about our products, but sometimes it's almost impossible to find information because we have so much documentation, so many blog posts, so many YouTube videos. It's hardly possible to process them all. Hi, my name is Pasha, and I'm a developer advocate for Bellsoft. And today we will fight LLM hallucinations in your product. But first, let's talk about several fundamentals. First, vectors. This is the base for all the LLM magic. Vector is just a set of numbers. You can think of it as an array of doubles, for example. Or, as a simple metaphor, imagine you need to distinguish New York from Tokyo. They have coordinates. In a way, these coordinates are vectors. It's just LLM that operates on multi-dimensional vectors. For New York and for Tokyo, there are only 2 dimensions, longitude and latitude. Vectors for our LLMs are much longer, usually 1861 dimension. For example, the second thing you should know about is a vector database. What's a vector database? Essentially, it's a specialized storage suited specifically to handle vectors. They can be usual databases. For example, PostgreSQL has a vector database. It's called pgvector. There are also different kinds of vector databases, for example, Milvus search or ChromaDB. And of course, Oracle has support for vectors too. What does it mean to handle vectors? It means that this database can perform operations on vectors very quickly. One of the most important operations on vectors is called finding distance, and one of the most popular ways to find distance between vectors is a cosine distance. Now, here is a small demonstration of what cosine distance is. Cosine distance is a product of 2 vectors divided by product of their powers. Now, imagine we have 3 objects: rose, sunflower, and sun. Sunflower is visually closer to rose than to sun, but how will it work for vectors? As you can see, there are 3 vectors, and they have angles between them. An angle between rose and sunflower is smaller than angle between sunflower and sun. And cosine is also smaller. And smaller cosine distance means more similar meaning. Now, you obviously asked me, Pasha, why are you telling all of this? Why do we care about vectors? Why do we care about cosine distance? Why do we care about databases? The answer is, this is a part of solution of our problem. This is a part of solution of LLM hallucinations. If you think about it, to browse through our documents is almost impossible for us, but it's very simple for robots. So there is a very simple approach to solve this problem. It's called RAG, Retrieval Augmented Generation. The workflow looks like this. We are taking a huge document, or a small document if we have small documents. Documents are just text usually, but also might be images and so on. Then we split every document into chunks. We take every chunk and we convert it to a vector. How do we do it? There are special neural networks which can do it for us. For example, OpenAI has one. And there are many others. Then, when we have a vector, we will save this vector to our vector database along with our source text. Because vector is just a set of numbers, it's impossible to decode a vector to a text without knowledge what was encoded. We have to preserve it. Then, when I want to find something in my documents, I don't have to read through my documents anymore. What I need is to ask a question to LLM. LLM should give me a vector for my question. Then I need to find the closest documents to my question in my vector database. Then I will put these documents in their context. And then I will ask LLM, given the whole information I just gave you, please answer my question. And now LLM doesn't need to hallucinate anymore. Now it knows an exact answer if it is in the document. If there are no documents, we can say it. If you're not sure, just tell us, I'm not sure, I don't have enough information. Now let's talk about how to implement this whole machine in our code. Obviously we'll use Spring. So the first part is to upload our documents to vector database. For that, I should remind you, we split documents into chunks, convert every chunk into a vector and save it to a database. Here's how we do it in Spring. The simplest way possible is just to have one endpoint. In my case, it's post mapping with /path, and we send the file, multi-part file in our case. Then I'm using TikaDocumentReader, which is a part of Spring AI suite, with which I convert my file to an actual list of documents. In this case, every document is a chunk that will be converted to vector. Then I'm just saying VectorStore.add docs. The whole magic here is hidden. Obviously, Spring will go to our neural network to convert every document to a vector, and then behind the scene it will go to the vector store and save vector together with source text. Then we just respond that everything is done. And to make our bot actually answer questions of our users or our own questions, like in my case, it is very similar. We'll have another endpoint, let's say getMapping, and we'll pass here the text of the question. Then we'll create a search query, query top-k build. This is an interesting part. It says, "Dear Spring, please find top 3 documents which are closest to our query." This is our cosine distance. Then we execute it on our vector store, and you can see that everything is abstracted out. You don't know what I'm running here, if it's pgvector or Milvus or ChromaDB, whatever. Then we get our documents, we convert every document to a specific format. In my case, it's title of the document and then text of the document. And I will put the file name, which is a part of meta information of my document, and I will split my documents by this delimiter, just to be sure that LLM won't mix up my documents. Now, I have to provide system prompt. I don't know if it has to be this complex. This is what I do, but you do you. You're a helpful assistant, you find information in data provided below. The format of the data is following my title, my body, text of the document or its part. The delimiter between document is this thingy. If you have to reference document, reference it by name. This is how we are not only sure that our LLM does not hallucinate, we can also go find the document by name in our storage and read the whole document. Sometimes it's useful. Always reference document where you found the information. If there is no information, you answer with a message, "Sorry, I don't have such information." You use the following information to answer the question, and then I interpolate my information there. Now, I have a very simple prompt. I just put my question of the user into it, and I'm creating a model with my question, and then I'm creating the user message, creating a prompt, and then I'm saying ChatClient.prompt.call.content, which will actually return me a string, which I can then return to a user. And this is the easiest, the simplest possible RAG workflow. It doesn't support chatting, it doesn't support anything fancy. It is very simple. But now you have all the basic information to know where to dig. Now, this is your Spring AI. It won't magically do your application smarter than you, but it will actually make your data useful. Finally. And hopefully, it will save you from some hallucinations. If you like the video, subscribe to the channel, leave a comment, and who knows, maybe I'll create the next one. Thank you so much. Pash out.